Okay, so let's look at what rational functions are. So rational functions are functions that can be written in a vulgar form, in a vulgar form or fractional form, vulgar form. Yeah, so when I say vulgar form, is the spelling right? Yeah. Can someone check it out for me? Vulgar. Just a minute. It should be AR, but I want to confirm. We coming in mathematics. No, I guess it's UR. Someone should confirm that for me, okay? Vulgar. Oh yeah, it's it's AR, okay? No UR. So they are typically any expression that can be written in a vulgar form. And I explain that, I mean, if you if it's put in fraction, then it's a rational function. Okay, so an example, I believe you know what fractions are, right? So an example is 2/3. So this is written in a vulgar or fractional form. So it makes that a rational function or expression. Yeah. Now, because we are doing advanced mathematics, we will be getting expressions with variables. So that's why we are using the term functions. So you would be getting other examples as 3x plus 2 all over 5x squared plus 6. You're likely to meet expressions like these. That is also what? Rational. Why? Because what you see on the screen is written in a fractional form, right? It's written in a fractional form. So it becomes rational and more and more. So we can also have 7x squared plus 6x minus 9 all over 2x plus 3. So is this rational? Ajua, is this rational?
Yes.
It is. So in general, we say that rational functions are fractions that can be expressed in a vulgar form. Okay, so if you have any expression of this form, let's say P of X all over P of X all over, sorry, P of X over Q of X. I'm using P of X to stand for a function. Okay, so an expression in X or Y. Okay, an expression in a variable. Let me say it like that, because the expression, it's not all the time involved with X. It can be different variables. Okay, so please, please listen to what I say. Okay. I'll be saying a whole lot of important stuff, not just what I'm writing on the screen. Try and listen to every single thing I'm saying. Okay. It's important. Yeah, so generally rational functions are any expression that can be put in a vulgar form. And yeah, i.e. So if you're drafting some notes, you can write Rational functions are functions that can be written in a vulgar form. Okay, then you come and add on IE. IE means what?
That is.
Yeah, that is. Then you do this P of X over Q of X. And this is what I'm explaining to you. So typically, P of X stand for any expression in a variable form. Variable can be X or Y. So look at what we just did here at the top. You see, it's an expression in a variable. The variable is X. Fine. Sometimes it can be Y. Okay. And then the denominator also is also an expression. Yeah, so I wrote Q of X to represent any other expression again. All right. Any other expression again. Mm, yeah, just a moment. Yeah, thank you. So, so yeah, that is it. So typically, any expression that can be put in this form is a rational function. Okay, that's phase one. That is phase one. Let's go to phase two. Another thing I want you to look at is, you see, so, I mean, because we're dealing with advanced mathematics, we will be looking at not just simple fractions as 9 over 2, 3 over, 4 and whatnot. Okay, but we will be looking at expressions that has variables amongst it. Yeah, that's what we'll be looking at. Okay, now back in school, if you remember, when you were learning about fractions, you remember you were taught about different types of fractions, right? We're talking about proper fractions, improper fractions, mixed fractions, and what have you. Okay, so for under this topic, we will transition to one heading called partial fractions, and because of that, I would like us to know what proper and improper fractions are. So I just want us to have a look at just two kinds of fractions. So we're looking at proper fractions and improper fractions. All right. Someone should time me, okay? It's 8:25 here. I assume it's around 12:25. So roughly one is 2:25, or let's say 2:50. We should close. So you notify me. Okay, so I want us to look at some two kinds of fractions here. Can we move on? Yeah, let's move on. Okay, I'm able to reduce the size. All right. Mm, right. Thank you. So I want us to look at two types, I want us to discuss two types of fractions here. Two types of fractions to be discussed. I'm adding that to be, I'm adding the last expression to be discussed, just so you know that we don't have just two types of fractions, but they are more. Okay, right. So we are discussing two two groups or types of fractions. Right. So I want us to look at um proper fraction and improper what? Fraction. So proper fraction, right? and improper fractions. So let's start with proper fractions. What do you know about proper fractions back in the days? What do you know about proper fraction?
The denominator is always bigger than the numerator.
Good. So can you give us an example just so we understand you?
2/10.
2/10. So with proper fractions, the denominator is big, the top is small. Do you understand? The denominator is big, the top is small. It's proper. Okay. Yeah. You can't, let's say for instance, we boarded a car, okay, to a destination, and the car lacks space. The car lacks space. So it happened that we have to be sitting on ourselves, okay? And let's say, for instance, Ahinkra is fat, okay? When it comes to body structure, he's fat. And we have one of these double trackers, and there's young ones, okay? Let's say Cassandra. Cassandra, let's say her size, she's very lean or small, very lean or small. Ahinkra is fat, like real fat, okay? It's not ideal that Cassandra should sit down, then Ahinkra sits on her. You see that? Yeah, Ahinkra sits on her. That's so improper. Yeah, so picture proper fractions as that. What is the ideal way? Ahinkra rather should sit down because he's fat. Then the one that is small sits on her, sits on him, right? So the fat one down, then the fat one, the big one down, then the small one on him. You got that? Yeah. So the bees is big, so something small should be on it. So the moment what is on top is way bigger than what is sitting on, then we are looking at what improper fractions. Thank you, Ajua. Now, this is just common fractions. So now let's look at this with that kind of fractions that involve variables. Okay. So guys, watch closely. When you have an expression involving variables, okay, for example, I've written some on top, so I'll just repeat myself. 3x, yeah, okay, so 3x plus 2 all over 5x squared plus 6. Every expression with a variable has a degree. Degree. In numeracy, when we talk of degree, is the same as power or exponent. Okay? I'm sure you may have heard of this stuff. Or another word is what? Index. Yeah, when you take a typical fraction, every fraction got, no, sorry, every expression got a degree. Okay, so now if you study what's on your screen right now, what is on your screen right now? Let's consider the top, the numerator. What's going on? When you take the numerator, what is happening? It has a degree, right? The expression is what? 3x plus 2. It has a power or a degree. What is that? What's the degree on x?
1.
1. It's 1. Usually when it's 1, we don't write that, so it's 1. All right. So it has a degree of 1. That's good. Yeah. So that is it. When you come to the denominator, it has a degree of what? It has a degree of what?
2.
2. Good. Now, what if there are other variables? For instance, as in the case of 7x, I'm building a point, 7x squared plus 6x minus 9. As in the case of this, you see that there are different variables over there. So what if there are there are a number of variables over there? It could be y whatsoever. When there are number of variables present, okay, And each variable has a degree. Like, for instance, here the degree is 1, here is the degree is 2. The highest degree is the degree for the whole expression. Okay, so if I ask you what is the degree of this expression, you go for the highest degree. So the highest degree here is what? Is what? 2, right? Are you listening to me? So if I ask you what is the degree of this expression, the degree of this expression is what? 2. The highest degree, okay, is the degree for the entire expression. In fact, that is what gives the expression a name. Please, do you understand it? Can I move on?
Yes.
All right. So now back at the expression I gave you, 3x plus 2 all over 5x. Someone calling me? Yeah, all over 5x plus 6. So with this one, now when you consider the numerator, the degree is what? 1. When you consider the denominator, what is the degree for the expression? It's what?
2.
2. So you see, so what kind of fraction is it? So the degree or its power is 1. The power for the base is what? 2. Oh, so 1 on 2. You get how the whole picture is. So this is also an example of a proper fraction. Because of course, the smallest is sitting on what is big. That should be the ideal way, right? Yep. We can do more. Can any of you volunteer to help me out with another example of a proper fraction? I'm gonna do one, the rest will be for you. For example, so we can have x cubed plus 2x squared plus x minus 1. X minus 1. Is this proper? Is this proper?
No.
No, sir.
It's not. That's good. What's happening? So what is the degree for the numerator, guys?
3.
3. And the degree for the denominator is what? 1. Right? So it's not proper. That's good. So now that you know that this is not proper, give me an example of an improper fraction. Sorry, an example of a proper fraction. One more example, then we move on, please. Just one. Just one. So you can have x plus 1, x squared minus 1. This is proper. Okay? Right. So that is it. Thank you. Then we look at improper fraction. I'm sorry. Improper fraction. Improper fraction. So with this one, of course, is that kind of fraction where the numerator is bigger than the denominator. Okay. Then you can look at 9 over what? 10. You see, the numerator is way bigger than the base. Or you let me use a number you'll be quick to see. So 9 over 3. It's improper. Have you seen it? Now, another example is this one, guys. This one. Let me write here. Improper. So you see. Oops, I'm sorry. Something popped out on my screen. Oh, man. Okay. Right. Yeah, improper. Okay. Not only that, So I got you one right. This is an example. There is one here too, guys. This one. It's also improper. Do you agree with me?
Yes, sir.
Study it closely. Yeah. So that is it. I have a syllabus here. I'm checking to see if I'm taking you in the right order. Okay, so I think I've discussed what it's suggested I touch on. Can I move on? Let's move on. Another thing I'm seeing here is I have to teach you how to investigate for the domain of rational functions. So let's look at that. Now, whether it's proper or improper, they are all rational functions. Okay? Okay. Can we move on, guys? Should I flip up? I'm flipping. Should I go on? Or someone is writing? Can I go on, guys?
Yes.
Okay. All right. So the next one. Yeah, so what we come to learn is investigate and how to investigate or find the domain. How to find the domain of a rational function. Of a rational function. I'm coming. Yeah. Okay. All right. To find the domain of a rational function, okay. First of all, you have to set or equate the denominator. Okay. You have to set or equate the denominator to 0. That's the first thing you have to do. And find the values. Okay. The values that makes the denominator 0. When you get that, then you tell the examiner that the domain of that particular fraction or function is the set of all real numbers, okay? Is a set of all real numbers. The domain includes a set of all real numbers, okay? With exception with the exception, okay? With the exception. With the exception of the values gotten when the denominator was equated to 0. So again, to investigate for the domain of all rational functions or expressions, first of all, equate the denominator to 0 and find the values of x that makes it 0. Once you get that, then you tell the examiner, oh, the domain of the rational function is the set of all real numbers with the exception of the values you had when it was equated to 0. We are going to make it practical, but let's explain what let's explain what real numbers are. Okay, let's explain what real numbers are because I want you to know what you are doing. That's not rocket science. Yeah. So let's look at what real numbers are. What are real numbers, guys, if I may ask? What are real numbers? After one hour, let's pause. Yeah, then we come back again. Yeah, what are real numbers? Anyone? Okay, so in numeracy, when we talk of real numbers, we're looking at rational, okay, and irrational numbers. After this, you'll get an idea of something. So real numbers encompasses rational and irrational numbers. What are rational numbers? Rational numbers are numbers that can be written in a fractional form, right? So any number that can be put in a fractional form is a rational number. And yeah, it's under real numbers. Okay. So yeah, let's consider rational numbers. So they are numbers that can be written in a fractional form, right? So if you are talking about rational numbers, we basically looking at fractions, simple fractions, right? Be it positive or negative. So you can have 3 over 5 or negative 2 over what? 5, isn't it? You can think of any fraction as far as it's positive or negative, and as far as it's in a fractional form. So can we say that whole numbers are rational numbers? Like an example one. Can we say whole numbers? These whole numbers, 1, 2, or negative 5. Can we say these are rational numbers? I want you to have an idea of real numbers. Can we say whole numbers are rational numbers?
Yes, sir.
Why?
Sir, please, because of the negative.
No, no. So in fact, when I was making that expression, I was quick to polish it quickly. Like this, I was saying that negative 2 over 5 is a real number because it's written in what? A fractional form, right?
Fraction.
Yeah, I said negative 2 over 5 is a rational number because it's written in a fractional form. Yeah. Yeah, once it's in a fractional form, that's what matters. It doesn't matter whether it's positive or negative. Okay, so can we say that 1, 2, negative 5, these whole numbers are rational numbers? I want you to have an idea, everything, real numbers. Okay, yeah. Can we say negative? Because you see, sometimes when you go to the examination hall, okay, elective math in particular, you'll be given a question. Then after solving, no, you'll be given a question and they will tell you that put, I'm trying to quote exactly how they represent the questions. They will tell you the answer must be a real number. I remember I took NOVDEC in Form 2 and I saw questions like that. So yeah, you go through the normal process, but if you don't really have an idea of real numbers, you ask yourself, so after going through this long process, arriving at the answer, is this my answer a real number at all? I always have concern. So I want you to know what real numbers are. And I'm saying real numbers includes rational and irrational numbers. So we are talking about rational numbers. We'll talk about irrational numbers soon. And you get to find out what real numbers really means. Right. So back at it. So does it mean 1, 2, -5 are rational numbers?
No.
No. Okay. Anyone else again? Anyone else again? Since yesterday, doesn't matter. Anyone else again? Ajua is a yes. Is a yes. Do you know why? Whole numbers can actually, whole numbers in general can be written as over 1. Yes, 2 over 1. Even so, when you cross multiply, you always have this notion, right? -5 over 1. Yeah, whole numbers ordinarily can be written in a fractional form are known to be over 1. So it appears as fraction, right? So it's rational. Yeah, so that is it. Oh, so whole numbers are also rational numbers? Yeah. Yeah. So you can see that when you study a number, whether it's negative or positive whole numbers, it's a rational number because it can be written in a fractional form. Have you seen it? Yeah. And fractions are also rational numbers. Now let's look at, so basically if you take a good comma textbook talking to you about rational numbers, it will tell you some example of rational numbers are number 1, integers. Integers are negative and positive whole numbers. Number 2, it will tell you, number 2, like ordinary fractions, proper, improper, mixed. You got that. Now, let's come to irrational numbers. So irrational numbers usually represent non-terminating decimals. What is a non-terminating decimal? There's a simple English word. Okay, come home. Okay, don't be thinking too far. What's a non-terminating decimal? It also represents recurring decimals. Recurring decimals. What is a recurring decimal? Yeah, who will help me out? Non-terminating decimal. So when we talk of, oh, come on, it's an English word now. What's a non-terminating decimal? If you say non-terminating, if I tell you your appointment is non-terminating, what does it mean? Grace, I've hired you at work. I'm telling you your appointment is non-terminating. What does it mean?
Say, please, I can give an example like 0.
I want you to explain the appointment is you. Or you prefer to give the example. Okay, you give me no, I don't think you really, okay, give me an example and let me see. It depends on how you put in it.
Say, please, for the reoccurring decimal or
Oh no, we are talking about non-terminating. If you want to give an example of a recurring decimal, then we'll come to that. When we get there, I'll ask you. But non-terminating decimal, what does it mean? I gave you an illustration. I have hired you at work and I'm telling you your appointment is non-terminating. Ajua, what does it mean?
Unending.
Unending. In other words, can you explain to the layman in simpler form? In other words, okay, Ahenkra, she's saying unending. So in other words, what is she trying to say?
So I can give an example.
Explain to me now.
I don't know how to put it, but I can give an
Okay, so
example.
it means that you are working with us forever until you probably die. Do you get that? Forever. Okay, so now I'll give you an example.
Let's say 1/3. When you change it to decimal, maybe you get like 0.3333. It will never end. So
Good. That's it. That is it. Do you understand? An example of a non-terminating decimal is, let's say, like you have a decimal which is 0.3333. It never ends. Yeah, it never ends. Some calculators, when you solve a particular question and it's non-ending, you see that to be 333, it ends and it climbs to the top like that. Some calculators, it does that. It climbs to the top like that. Or sometimes it does this. Watch. Sometimes this is what you normally will see on some kind like this. 0.333. You get that 333. Then it would put a line on top like this. It means it goes on 3333 like that. Non-terminating. You know, the calculator has a limit, so it will put this bar there to tell you that it continues, it doesn't end. Because if it's a non-terminating decimal, it's not wise to do 0.33333, then you end it there. That means that that's not the answer. And you and I know that the answer goes beyond that, isn't it? So the calculator will put a line on top like this to signify that. Please, I'm coming. When this thing come, how will I? It's fine. Yeah, so when the calculator does this, it tells you that it's what? It continues. Okay, that is it about non-terminating decimal. How about recurring decimal? How about recurring decimal? My dear, you can come in now. Ah, it looks like, okay, it's fine. I thought someone had raised their hand. Recurring decimal, yeah, come in now.
It means numbers that come after the decimal follow a certain pattern, like
Pattern.
0.16, 0.16 continuous.
Like 0.1616161616. It's recurring. It's recurring. Please you understand. So now, having discussed what rational and irrational numbers are, can you ever think of a number that has existed in the world that is not under real numbers? Maybe you've thought of a number you think it doesn't fall under the category of rational and irrational numbers. You can bring it on. Any number you are thinking about is here. It falls under one of these headings. Have you thought of a number that exists in this world and is not under this category? Nope. So that means any number in the world is a real number. Do you understand? It's a real number. So in exam, solve, leave your answer. Your answer must be a real number. You know, any answer at all is a real number. Do you understand? Okay, back at what we're talking about domain. So I said you set the denominator to 0. Then now, with the result you get after setting it to 0, you tell the examiner, oh, the domain of the rational function is a set of all real numbers. Okay, with the exception of the values you. So yeah, let's put it into practice. I'm going to give you an example. Can I flip up? Can I flip up? I'm come to give you questions. Can I? Can I? Is anybody writing?
Yes.
Okay. Okay, so let's go. Cool. Get ready. Okay, so if just a moment. Illustrating. Examples. So if the function of the real variable x, okay, is defined as okay. Okay, so let's express it. So it's defined as f of x maps to x squared plus 2x plus, sorry, minus 8 x minus 1 x plus 3, or x is real. And I believe you know what it means, right? Where x is real means what? It means what? It means
A
what?
real number.
A real number, yeah. So find the domain of f. Right. So I guess I'm gonna do this, right? I'm gonna do this one, then you do the rest. Are we ready? All right. So let's see, solution. So I'll do this one, then you do the rest. So to begin, I said what? Set the denominator to 0. Oh, the denominator is x minus 1, x plus 3. Okay. So to begin, first set it to 0. So you're gonna have x minus 1, right? X plus 3. So you set it to 0. That means you equate it to 0. Then you solve. Now look, be smart here. You remember quadratics factorization, right? Factorizing quadratics. You notice that when you have a quadratic and you factorize, at the end of the day, you end up getting an expression in two different brackets equals 0. Yeah. When you have a quadratic, if I give you a quadratic x squared, okay, plus 3, let's say 3x minus 2 equals 0, and I ask you to factorize, you end up having two different expressions in brackets equals 0. Yeah, that is it. And at this juncture, you normally do continue. You normally do continue from here. So be smart here. It's already factorized for you. So don't try to remove brackets by expanding. If you expand, you get a quadratic and you would have to solve using the methods to solve quadratics, factorization or whatsoever. And you still come and land at this. So that is it. So here, what do? You just take 1x minus 1. You equate it to 0. X will be equal to what? 1. Then what else again? This one to x plus 3, you put it to 0. X will be equal to what? Negative 3. Please, are you listening to me? Are you listening to me?
Yes, sir.
Yes.
Yeah. So that is it. So first equate the denominator to 0. When we equate to 0, it gives you some values. It gives you some values. That values, you see, this is a function. It has variables x. What the variables means is that you can think of any number. It's now appearing like a code. The expression is appearing like a code. So you can think of any number. Once you have a number, you can just come and put it on wherever you see x's, and it will give you a result. Good. Now, so that is it. It will give you a result. Now, the reason why I always encourage you to set the denominator to 0 is that we are dealing with fractions. In fractions, any fraction with 0 on the denominator or any fraction with the denominator being 0 is an impossible fraction. It's not plausible. You cannot try that. Just think of any number. Think of any number 9. Oh, would you see my screen? Think of any number 9. The moment you divide by 0, the calculator, sorry, first of all, let me go back. Think of any number 9. I've divided it by 0. The moment, I'm not sure, can you see properly when I show my calculator? If you can't, you can do it yourself. Think of any number, divide by 0. The calculator will signal that that's a math error. It's not plausible. So what I mean is any fraction with 0 on the denominator, like that with the denominator being 0, that's the right expression. It's not plausible. You can do that. You can do that. So what it means is anything that, because here is a function, that means variables are in there and you would have the opportunity to put in numbers there. Now, any number that will make the base 0 is not part of the domain, because the moment the denominator becomes 0, the whole fraction becomes impossible to solve. Like it will give you error. Yeah. So that's what I'm saying. So the domain of this is any number in the world can give you. So I'm explaining what domain is. So if you ask me the domain of this is what, I'll tell you, oh, the domain of this is any number in the world Okay, it's any number in a world. The domain of this is any number in a world. Okay, because any number in a world would give you results, with the exception of numbers that will actually make the denominator 0. How will I investigate that? I'll just take the denominator and equate it to 0. X minus 1, x plus 3, equate it to 0. It will give you certain values. Yeah. That values, when you put it there, it will make the base 0. You can try it. We had 1, right? 1. Think of 1. The base, if you are substituting 1, you have 1. You have 1 minus 1. Okay. Whatever you see x, you put 1 there. Over here, you have what? 1 minus what? 1 plus 3, right? 1 minus 1 is what? 0. So it will be 0 times what? 1 plus 3 is what? 4. 0 times 4 is what? 0. So you see, when you are slotting 1, okay, the base, if you are slotting 1, it would turn the base to 0. That means the expression will be so and so over 0, and anything over 0 is not solvable. Well, if solvable is the right mathematical way. Yeah, so that is it. Now, -3 is also another one. That means wherever you see x, you put -3 there. So -3 minus 1, then another bracket, -3 plus 3. -3 minus 1 is -4 times -3 plus 3 is 0. -4 times 0 is still 0. You see? So any number in the world can actually yield a result for your fraction, with the exception of 1 and -3. How would you get 1 and -3? All the time, just equate the denominator to 0 and it will come out. I would mean. So, mind you, this was just rough work to let you know the usefulness of that 1 and -3. The question says, find the domain. So, after setting the denominator to 0, here, this is how you write the domain. So, you just write domain, okay? Domain. Yeah, domain of the handwriting don't look good. Domain of f equals, okay, then you open a curly bracket. See, it's not any other bracket. A curly bracket equals x. You have done this back in school. Who can help me continue? Opening a curly bracket should give you an idea. Anyone to volunteer?
X.
You forgotten?
I remember, but then I don't know how to say it.
So S is such that.
Correct. I'm coming back. I think I will not get space here, so let me bring it to the down. Okay, yeah. So domain of f is equal to x is such that x
is equal to all real numbers.
So here we use the word belongs to. That's how you write belongs to. Let me see. Okay. Yeah, we'll manage like that. Belongs to all real numbers. How isn't it? Please, are you there?
Yes.
Then continue. Comma. X should not be equal to what? 1.
1.
Or what? -3, right? We have -3, isn't it? 1 and -3. So
Yes.
1 and -3 will make your denominator 0, and the whole fraction will be impossible to solve, right? So x shouldn't be equal to 1 or -3. Oh, apart from that, x belongs to any number in the world, any number you can think of. If you put it in a function, it will make sense. It will yield a result, right? With the exception of 1, it will yield result. And you know, any result, it will yield result. Any result is a real number. Any result, whether you are a non-terminating decimal, recurring decimal, fraction, even whole numbers are fractions, right? So X is any number in the world. Any number in the world will give you a result. Even if it's 0, it's a result. Do you understand that? With the exception of 1 or -3. Do you know why? 1 and -3, if you put it on a calculator, it's not like it gives you an answer. It will flag it, stack error. So meaning you don't get a result. That's what domain means. I want you to understand the concept and not, I've solved, you equate to 0, you get there, so you are doing that. Okay, math should be practical. It should be understood. It's not rocket science. It should be understood and not, chewing them like that. You produce verbatim. Okay, so generally, I believe you understand the concept of domain, right? Right?
Yes, sir.
Yeah, so your solution should be this. You set it to 0. Then you come and write the domain. The rest I'm coming to give as yours. Grace, do you understand what we're doing?
Yes, sir.
Ajua.
Yes.
Okay. I've already gotten a response from my person. All right, now the following is yours. First question. The function right, let's go. Oh, sorry. Let me number them. So number 2, example 2, right? The function, the function g of the real variable x is defined as g of x 1 over x plus 3 states the largest possible domain. The other student that couldn't join, notify them if you know them in person, but I'll also reach out to them after the lecture. Alberta and some couple of students. Yeah, Jim. Just a moment. Yeah, the domain of Jim. Oh, why is it not coming? Yeah, because you're more than this. Man, or that to. I'm trying to write, it came. So find the domain of the largest possible domain of G. Let me give you another one. I have one here. Yes, we'll be doing it. Number 3. No, you do it and tell me on because I need space. Okay, I'll mute myself and wait for your solution. When you do it, you can text it to me on WhatsApp. I'll be waiting.
Like, we should send you a picture of it.
Yeah, do it. Send me a
WhatsApp.
picture of your solution on WhatsApp.
Okay.
Mm. My people, I'm so sorry. Okay, I had to check what's going on in the office. Ahim Cross Centers. Oh, two of you. Okay, let's see. Let's see. Ajoa. Right, you set it to 0. Okay, right. Great. Let's look at Ahim Kora. -3. Good. Your presentations are awesome. I'm coming. And Grace, yeah, Grace, I'm coming just a moment. What's her name? Madam Precious. Okay. Where's Grace? Grace. Oops. Please, I will check your previous assignment. Okay. Good. All right. You guys are doing well. Let me see. Let me give you one more. Then we move to the next. Let me give you. Okay. Yeah. For the purpose of the video lesson, I have to solve this. Okay. Solution. Right. Solution. Yeah. So first, you set the denominator to 0. So they ordered that they had x plus 3 equals 0, and they notice x equals to -3. So what happens, Adjoa, if you put -3 at the denominator, what would the expression be? And what will be the result?
Wait, I don't get a question.
So we set the denominator to 0. We're getting x as -3. Okay.
Yes.
So now when you put -3 at the denominator, what will be the expression and what will be the end result? When it's slotted there, you get wherever you see x, it's be -3. So it's be -3 plus. Are you following? Is anyone following? If you get a picture, help us. Oh, I'm saying when you, yeah, there's someone on the floor now. I'm saying when you, so what happens is when you put the denominator to the -3 to the denominator, you end up getting -3 plus 3, which is 0, right? The new expression is this. So in the end, the base will be 0. So you have 1/0. Punch 1/0 on your calculator and see. It's undefined. Do you get it? Put 1/0 on the calculator. It will give you
Yes.
math error. Yeah. So that is it. So it's like any 1/x plus 3. The x, you see, it's like a code. So the x represents any number you can think of. Okay. If you put any number there, the fraction will give you a result, with the exception of negative what? 3. That will give you math error. Good. I'm going to give you one more. Then I move on to the next. So this one is yours. You do it, then you send me a picture of it on WhatsApp. Number 3. Number 3. Determine. Some of them you have to also be smart. You use ideas you have gotten from algebra. Okay. The domain of the rational function. F of x equals 1/√of x minus 2. Right. Do it and let me know your thought. Some of them just use your ideas, the idea you have in algebra. Yeah. I deliberately brought this question. Oh, you're working on it? Or you want help?
Um,
Mm-hmm.
like
Mm-hmm.
I know, like I have an idea. Like I know
Okay.
how to do it low key, but then like should
Mm-hmm.
I like write it in like a sentence form?
Okay, you can, for now, you can write in a sentence form. If it makes sense, I'll help you write it, like explain it mathematically. Okay. But I think in exam, even if you write in a sentence form and you get a marker who is soft, an instructor who is soft, the person can consider you. Yeah. Yeah. You can be considered. For me, if I'm marking it, what you've written captures everything it should be, I'll give it to you. Yeah. Mhm.
Hmm.
Mhm. Yeah, I'm waiting.
Can I say something?
Yeah, go ahead. Feel free.
Okay, so I'm stuck.
Okay.
But then, like, I know the answer.
Okay,
I
so
know what
you
you need
talk
to
to
do.
me. Now let's talk. I think we should communicate. So bring your ideas on board and let's see. What
Sir,
will make this whole
please,
thing? Uh-huh.
sir, please, I've tried. Can I send it to you?
Yes, you can share yours also. Yeah. You can share it. Yeah, Joa, you want to say something? Yeah, let's talk. We can talk.
Okay,
So,
so
mm-hmm,
in this expression,
mm-hmm.
the denominator is in a square root.
Yeah, that's true.
Yes, so like when I checked, it's not only the number 0 that
Mm-hmm.
makes it undefined,
Yes.
but also like the negative
No,
numbers.
wait. If you are saying it's not only the number 0, I would argue with you. Do you mean like if you are saying it's not only the number 0, you mean it's not only when we try to put 0 there? Oh, no. You see, it's quite vague. If you say it's not only the number 0, what it means is that like when we are considering the number 0, as in wherever you put x, I mean wherever you see x, you put 0 there. It's not only 0 that makes it only fine. It's kind of a wrong expression. I know you mean it's not only when the whole thing at the denominator is equated to 0 that makes it undefined, right? And crowd continue.
Yes.
Yeah, it's not, yeah. So it's not only that, but what? Continue. Mm,
But also the negative
mhm.
number. The
Yeah,
negative numbers.
yes, negative
Or
numbers. You are right. Yeah, you are right.
okay.
Square root of negative numbers are not plausible too. Yeah, in class saying something, let me check. Yeah, you are right. So I'm gonna help you put it in the right way. Let me see what he has here. Mm, mhm. I disagree with you, Ahinkra. Square root of, but why are you using, let me check his previous example. But in your previous example, you didn't use not equal to 0. So why are you using, do you know, Ahinkra, do you know the not equal to sign?
Yes, sir.
In your previous example, you never did x plus 3 is not equal to 0. Why are you now using not equal to 0?
Sir, because of the negative. Hey, because of the root sign.
No, still, it doesn't make sense. Like you're doing this root of x minus 2. That's not what I taught you. It's not equal to. Why is it not equal to 0? If it
Um,
shouldn't be equal to 0, then don't solve. It's not equal to 0, then why are you solving? Wait, I'm trying to make a sense in what you say. It's not equal to. It shouldn't be equal to 0. Hmm. And then he did another thing. Greater than or equal to 0. I may actually agree with you with this one. It's not equal to 0. Okay, I may agree with you with this one. And then your next one is x minus 2 greater than or equal to 0. And you solve further by saying, in the first place, x minus 2, when it's greater than or equal to 0, I mean, it doesn't make it undefined. Like, it's part of the domain. It's part of the domain. This one is part of the domain. It's part of the domain. X minus 2 greater than any number which is greater than 0 or equal to 0 is part of the domain for this expression. It's part of the domain. Yeah. So you are using a like wrong sign. Okay. Let
No,
me
sir.
come.
With this one, I was trying to cancel this one.
Not greater than or equal to 0.
Yes, sir.
Not greater than. Then what? Then the answer is not complete. Oh. If it's not greater than or equal to 0, so I'm coming. So x, I think he will solve further. X is not greater than or equal to 2. So if it's not greater than or equal to 2, then what? Then what is the domain? So the domain is any number in a world can actually yield a result for this, with the exception of when this is whether he said is even not equal to 0. With the exception of when the b is not 0, so 0 is 1. Then here, then what? You are making it complicated because I'm a teacher. I'm trying to make sense of what you are saying, but like it looks complicated, guys. With what we've learned so far, what is the domain of a rational function? Before you begin, how do you find domain? Before you have to look for what will make the fraction undefined, right? So before you begin, what would you do? You set the denominator to 0, right? Then we come to what Adjoa is saying. Before you begin, what do you do, guys? Solution. Solution. Before you begin, what do? You know that root of what? Before you begin, don't you set the denominator to 0? Don't you? Adjoa, this is one of the things you do. That's the first thing. You said it. So you can solve
Yes.
this now. Yes. How will you solve this? How will we solve this, guys? How will we solve this? Just square this side so that it cancels off. And math, whatever you do on the left-hand side, you have to do the same thing here, right? Sorry. So what? Squared, isn't it?
Yes.
Yes. Now it has cancelled. So what are you getting? Isn't it x minus 2 equals what? 0 now. So what are we getting? X minus 2 equals, sorry. What are we getting? X is equal to what? X is equal to 2, right? Guys, are you there?
Yes.
Yes,
X is
sir.
equal to 2 now. What? Okay, we are coming. What does this mean? What this means is that expression, the question in the function f of x equals 1 over root of x minus 2. What this means is that the b's, if you are to substitute, the end result we had was 2. If you are to substitute, substitute 2 at wherever you see x, it will be what? 2 minus 2, right? That will be 1 over root of 2 minus 2 is what? 0. Okay, root of 0 is 0. Hey, the denominator has become 0. Come on. So it's not plausible. Okay, you see? So the domain for this, listen, the domain for this is 1 over root x minus 2. Any number you can think of, when you put it there, it will give you a result. With the exception of 2. Why 2? Because if you slot into 2 will make like the base 0, and any fraction with the base 0, it's not possible. So the domain of this is any number in the world will make this possible, with the exception of what? When you set the base to 0, I mean with the exception of what? 2. But not only that, if you, with your knowledge in algebra, not only that, all the numbers in the world, there are other stuff that can make this not plausible. That is when Adjoa comes in. Adjoa, talk. We are listening to you. Please hold on. Let me turn off my video. I want to get some water to drink. Yeah, Adjoa, talk. We are listening. Not only that 2 that will make the base 0, that makes it impossible. The fact that you are seeing a root sign in the denominator, for square root, something makes square root impossible. How do I talk?
Negative numbers.
Mhm. I think do you have a calculator?
Yes, sir.
Scientific calculator with you.
Yes, please.
Okay. Great. So do you have a scientific calculator with you?
Yes, sir.
Okay. Okay. So everyone put in square root of -1. Tell me what you get.
Is it I?
You are getting I with yours, eh?
Yes.
Yeah. So it's not plausible. It cannot be solved. The others, what are you getting? Let me check.
10.
Yours is giving you matter, meaning I just using some advanced kind of calculator. Okay. Anyway, Grace, what are you also getting?
Math error.
Okay, let me check from mine. Square root of what? I said negative. Square root of negative what? Anyway,
-1.
1, yeah, matter. Yeah, you see, you can do square root of -2, -3. Square root of negative numbers are matter. So, oh, let me turn my video back. So guys, this is the denominator. The denominator is root what? X minus 2. Anything that will actually yield negative here. Anything that would like yield, like it will, anything that would give a result of negative under the root, the square root of negative value will become a problem for you. So what numbers can we consider that will change this thing to negative? So it's x minus 2, right? X minus 2. If x is 2, that one, it will be 0. We've dealt with that. So think of 1. 1 minus 2. 1 minus 2, do it. 1 minus 2 is -1. Okay? 0, think of 0. 0 minus 2. 0 minus 2. Okay? 0 minus 2 is also -2, like it will be negative. Now, from 0 to continue, from 0, if you're going backwards on the number line, what happens? You have -1, right? -1 minus 2. What are you getting? -3.
-3.
You see, go backwards again. From -1, when you are on the number line, you go to -2, right? -2 minus 2, -4. So in summary, what are we saying? Anything that would create a negative value inside the root is also part of the things and the numbers that would make the whole fraction undefined. So in summary, you say that yeah, first of all, you set x equals 0, you get into, you know the behavior of 2, right? Yeah, so you can say that. So let me climb up. You can continue after this, and you can talk also. Since the values are under a root, okay, are under a root, it is undefined, okay. That's why you can talk in a language you understand. It is undefined for values of x less than what? Less than 2. Do you understand? Yes. Because any value less than 2, that means if you're thinking of 1, it will make it undefined. Anything less than 2, 1, 0, less than 2, 0. Oh, -1, negative, all of them. If I do x is less than 2, x is less than 2. Yeah, x is less than 2, meaning all the numbers you think of is there. All right, so domain. So you can just say that domain is equal to, no, domain of, I think the question said G or f of x, domain of f of, oh, sorry, of f of x, right, is equal to x is such that x belongs to all real numbers, all right? Please, are you there? Except what? When x is what? X is equal to 2. Not only that. Any value less than 2 to right. So you can just say except when x is less than or equal to 2. Meaning when x is equal to 2, I can hold 1, I can hold 0, part of it, -1, part of it, -2, part of it, -3, any negative value. All right, we are done. Any question? Any question? Please, do you understand? Grace, you get it? Grace.
Yes.
Right.
Yes, sir.
Adora, do you get it? Adora, do you
Yes,
understand?
sir. Yes.
Ahinkra, you get it, right?
Yes, sir.
All right. So I'm going to give you some questions under this. As per my syllables. The next thing I'm to touch on is range. Okay, so I'll use this to end the lecture because I want you to save your data. Next time you have the class in the lecture in the classroom. So the next thing we're going to touch on is range. That's what the syllable says. How to find the range of rational functions. So the range. Finding the range of rational functions. All right, just a moment. I'm trying to call Madam. She's not picking up. So let's continue. So basically, when we talk about the range of rational functions, it's it means the values that makes the function defined. We are looking at the values that makes the whole function what? Defined. Please, you understand? We are looking at the values that, yeah. Can you hear me? Who is on the
Yes,
floor?
please, I can. Sorry, it's Madam Precious.
Okay, madam, I'm listening.
Yeah, you're trying to reach me. My bundle is finished.
Okay,
I'm
the
trying to.
meeting is recorded, so we can't hold conversations like this here. But yeah, I wanted to find out how was it with the connection. If your bundle is finished, get into the school's account and get some for yourself.
Okay, thank you.
And then you connect. I wanted to know I mean, how was it after joining our meeting? How was it with your projector in the class? the view. So do that and get back to me.
Working on it and my bundle got finished.
All right. So kindly do that. Thank you. Okay, guys, let's continue. Yeah. Can we move on? The meeting is recorded, so I wouldn't like such interference. All right. Yeah, finding the range of rational functions. So we're looking at values that makes the function defined. Okay, so we are not looking at the zeros. We are not looking at the zeros of the function. Okay, so how do we approach that? So normally we try to look at cases where the numerator and the denominator are actually linear functions. I'm going to give you a question, an example, and then I will illustrate it. Illustrative example. Find the range of the function f of x yielding x over 1 minus x. Okay. Okay, so solution. So we're looking at any possible value that will make this whole thing defined. Defined. Guys, defined though. Yep. So let's see. So first off, let f of x, okay, be equal to, let's use a variable y, okay, to represent it so we can solve it easily. Can we move on?
Yes.
Yeah. Pay attention. The next one. Now, I want you to know that after this lecture, I'm uploading into YouTube and then your page so you can go and watch it over and over again. But that's not an excuse to skip class. Because if I notice that going forward, the other students, your attendance have dropped, I'll not record the lessons anymore. All right. So, yeah, you make it. So, wherever you see f of x, change it to y. Okay, just put y there. All right. So, now we put in a form of an equation. Okay, so y equals x over 1. Here is looking at a relation. We are putting it in a form of an equation. Okay, so 1 minus x. Okay. Now, and at this juncture, you see our interest is on x, right? We're looking at any possible value that makes x defined. That makes, like, when it's slotting for x, it makes sense. So we are going to make x the subject here. Good. So how would we do that? You're a science student. I mean, this should be quite easy. What do? We cross multiply, isn't it? Help me out.
Yes, sir.
Yanko. 1 minus. Now, yes, sir. No, none in your equals what?
X.
X.
X. Good. We are still making x the subject. Okay, let's expand. Go.
Y minus XY
xy.
equals X.
Good. Next is, because we are making x the subject, anything that contains x, let's go and group them at one side. Let's go.
Y
Y.
equals X plus XY.
Good. Then now you make x the subject. Let's go.
X.
No, like, sorry, factorize x out. We can actually make x the subject here
Oh,
without
okay.
factorizing. You get it?
Okay.
So
So Y
here,
equals X
like,
plus X bracket
good.
1 plus
1
Y plus X.
No,
1
it will be
plus Y,
y.
sorry.
Yeah, y. But do you understand?
Yes, sir.
Yes.
Good. So now let's repeat the whole thing. But this time I want x to or like write the x part first. I'm just kind of turning it. Okay, equals y. Now, what do? You divide by whatever, which is at which is what?
1
1
plus y.
plus y.
Okay. Then you have to, it cancels. X is equal to what?
X is
Y
equal to
over 1 plus y.
1 plus y. Okay. Okay. So the question, I'm coming, we are done. So the question is find the range of this function. The function is f of x, right? Okay, pay attention. So tell the examiner range, oops. Tell the examiner range. Oh, why is it not writing? I choose you. Okay, it's coming. Tell the examiner range, okay, of y. Okay. No. Why we introduce this? So let's say, let's use what was given in the question. So the range of f is equal to x is such that that function. Sorry, why are we using
Is it
x?
supposed to be range of f of x? Or
Yeah,
just
f
range of
x.
f?
Okay, we can do that if that's what we want. I'm coming. Let me erase. And I'm even introducing x here. I'm sorry. We are looking at, you see, they said range of the function, and the function is f, I mean, well, f of x, y, whichever way it is. If you write f2, you're not wrong. Okay, it's equal to f, or in other words, you know, x is f of x is what we are saying. We want to use y to stand for it, right? So y is such that y belongs to all real numbers. Please, are you listening to me? Except when y is equal to, when you set the denominator to 0, what happened? When you set it to 0, what happened? Y
Get
will
it.
be equal to what? -1. So except
Negative
when y is equal to what? -1. That's the range. Please, are you there? So the range of the function is what? F of x is such that f of x belongs to, that function belongs to all real numbers, with the exception of when, you know, you set up the denominator to what? -1. Are we together? I will try to flip down for you to see what went on at the top.
Y -1.
Oh, when you set the denominator to 0,
This on
see,
the
when you set the, you see, we are looking at the range of the function. Okay, we are looking at the range of the function. The function is f of x. I mean, in other words, y. We are using y to represent that. I would mean, so the range must be written with relevance to y. Okay, so now we have to, you know, do a whole lot of change of subject here so that y will be within the equation, which we've done that. Now, y, the base is what? 1 plus y. So if you set it to 0, I think we are getting y is equal to what? Is it not -1? Have you seen it?
-1. Yes.
Yeah, all the time you have to do that. So meaning any value of y you put in a function, it will yield a value of what? X. With the exception of when y is equal to what? -1. And you know how it's going. If you put -1 there, the base will be 0. Any fraction with a denominator as 0. Please, are you listening to me? So, you know, when I started the lecture, I'm saying that when we talk about a range of a function, we are looking at any value or of y that actually makes x defined. If we talk about range of a function, so if we are talking about range of this function, we are looking at any value of what? Y, or the function that makes this x what? Define. Do you understand? Now, so we are saying that, so this one means y. So y is equal to x over 1 minus x over 1 minus what? X. So we are saying that any value you put for y, it will give you x, a value for x. Please, are you listening to me? We can think of one. Let's think of any number. Let's say 3. 3 will be equal to what? X over 1 minus what? X. Please, are you listening to me? So cross multiply. You get what? 3 times 1 minus x, right? Is equal to x, right? That'll be what? 3 minus 3x is equal to x, right? Let's send the 3x over there. That'll be x plus what? 3x, isn't it? 3 is equal to, isn't it 4x? Feel me. You divide by what? 4. If you divide by 4, what happens? X is equal to, is it not 3 over 4? Haven't you gotten a result? Is this not a real number? It is a real number. I think I have to zoom so you see clearly. We are getting do you see it properly on your screen since you are using a phone?
Yes, sir.
We are getting 3 over 4. Is it not a number? It is a number, right? Okay. The same function, that's y equals the same function, that's y equals or f of x equals what? X over 1 minus x. Let's think of another number for y. No, let's use the -1 we had for y. Y is what? -1, right? So it will be equal to x over what? 1 minus x minus 1 times the b, so that will be, you have -1 times what? 1 minus x. Grace, I hope I'm not confusing you. Same as Ajuan.
No, you're not.
Yeah, we are just doing proving. All right, so here -1 times 1 is or -1. -1 times x is plus what? X equals what? X. Okay. Are you seeing what I'm seeing? -1 will be equal to what? X. When you cross it to go x minus x. So the whole thing is that if you are putting -1, it will cause a havoc. Does this make sense? What is this? -1 equals 0. What is this? Oh, that's why we are saying that. When they ask you of domain means all the value, any value of y that makes the whole expression of for x makes sense. So any value of y that makes x defined, that's the domain. So I'm telling you that the domain of that question, range. When they ask you what is a range means any value of y that makes x defined. Okay, so what is the domain of this? Oh, for this one, the domain of this is that any number in a world, if you choose it for y, it will give you a result for x with an exception of -1. Do you understand that? Because if you put -1 there, it will just cause havoc. But apart from that, any number you put there for y, the expression y is equal to x minus 1 of 1 minus x will make sense. Please, any question? Do we understand?
Yeah.
Now, how would you be able to get that -1? So that's what I'm saying all the time. Introduce y to represent f of x. Then you make x the subject. That is all. This brings us to the end of the lecture. I'm going to give you questions on domain and I'll give you questions on range. This recorded session will be uploaded for you to watch. You can subscribe to the channel so that when there is any upload, you'll be able to have access to it and you turn your notification bell on. All right, at this point, do you have any question, my people? Do you have any question?